Okay, so a web stack is basically a stack of technologies used to create a visible browser experience to a person. Okay?
Okay.
So in the web stack, we have a bunch of different layers. You can have some websites with like only a few things in the stack.
Mm-hmm.
You can have the browser itself. The browser reads from something called the DOM. So we have browser, i.e. Firefox, the Chrome, Opera, Edge, etc. Okay. From there, we have the DOM. What the DOM is basically a bucket with your page content in it. Okay, so let me think of a good way to explain this. So the DOM, and when you write code into a page, or not into a page, you don't do it into a page. When you write up code like on a screen like this, in a text editor, all that gets sent up to the DOM, and the DOM just holds it there for you.
Oh, okay.
And the browser comes along and looks at the stuff that's in the DOM and picks up pieces and goes, oh, I know what this is. And then it renders it on the page for you. So it displays it on the page. Now, the DOM is important because if sometimes the developers will find that Internet Explorer will pick up something from the DOM and go, what the hell is this? I don't know what this is. I'm going to make it look like this. And Firefox will pick it up and go, oh, I know what this is. This is what it should look like. And Chrome will come along and they'll pick it up and go, oh, I know what this is. I'm going to make it look like this. And when it opens up in all three browsers, it looks and behaves differently because the browsers are interpreting the DOM in different ways.
Okay.
Okay, so the DOM is basically the essence and idea of the developer's code in a centralized single location that gets sent to the user, and whatever browser the user is using then takes everything in the DOM and interprets it onto the page for you.
So you have to know how each of the browsers will take the DOM.
Exactly.
And so that way, when the Explorer takes it out, they can all look the same.
Yep. So essentially, what you end up having to do as a browser developer is you have to know how each browser is working. And then when you send things to the DOM, you basically say, okay, if your Internet Explorer use this, if your Firefox use this. So when the browsers come along, they go, oh wait, I don't know what these are. These are for Firefox. They're not mine. I'll pick it up and look at it and go, oh, I know what this does. Here you go. Firefox will come along and go, oh, that's Internet Explorers. I don't want that. Pick up Firefoxes and goes, oh, I know how to do this. And while they might be different pieces of code that all look differently in the code itself, the intention is that the user experience will be the same regardless of what browser they use.
Right.
So the DOM is a holding area for code before the browser interprets it.
Okay.
Okay. Any questions on that so far?
No, that makes sense.
Okay. So that's the... Okay. Down from the DOM, you have the web server sends responses to the user. Now, what that means is that when a user says, let's go to www.google.com, that sends a request out into the ether and says, hey, I'm looking for this address. whoever owns google.com will hear us calling and say, here I am. And it'll send back a response to us and say, okay, what do you want? So a web server does nothing more than respond back with messages that it's expecting to hear in ways that it's expecting to respond.
Okay.
Okay. So
it's like a butler.
Yeah. Yeah, it's like a butler. So if I open up, try not to get too freaked out by this, but I'm going to come in here to the code.
Mm-hmm.
If I go to network, is it network? I think it's network. Yeah, so we can see here. See if I can move this. Okay, so we have all of these. Let me. Can I? Okay, so here, this is in Wikipedia's, right?
Mm-hmm.
We have this placeholder.html. So we basically say, hey, I want this information.
Okay.
And it responds back. Can I zoom in on this? Yeah. It responds back and says, okay, you want this page? Well, everything from that page is this.
Okay.
And this. And this. And this. So it sends back all this information to the DOM.
Mm-hmm.
The DOM then sends it to the browser. Browser then interprets it and puts it on the page. So the web server, like the butler,
Mm-hmm.
but you have to ask it the right questions, right? So if say up here, I was going to type in chupacabra. I'm going to hit enter. It's going to go. It's going to give me the vModel chupacabra page, which doesn't exist. So it loads in different content. So you said, hey, give me this, and the website goes, or the web server goes, I don't know what the hell that is. So here's my default response when I don't know what you're trying to ask me. So it should look the same if we say buffalo. Same stuff. So it doesn't know what we're trying to say. It's not within its parameters to understand us. It's like Billy Madison when he walks up to people and he speaks in his goober voice. It's essentially what we've done to the web server. We said, hey, and it goes, you're retarded. Here's some things to help out people who are retarded. And it gives me other information. Developers have seen this. And let me see if we can...
So it could be almost like, as a butler, say like, I want to see this, but it doesn't recognize it, and it's going to say, well, are you asking about this?
Yeah.
Give you a list.
If the developer wants to make it that way, then they can. Here's security metrics, and I just typed in taco, 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 taco after the URL, and we return back this 404 and say, we have no idea what you're talking about. In this case, we're returning back a 404. You see that there? It disappeared, but we returned back a 200 afterwards because we loaded in the 404 page correctly. So you have all these different responses that we can get.
Okay.
So you might see things like 200 OK or 404 not found or 500 internal server error, things like that. But those are all different responses that you get from the web server based off of how you're talking to it, how you're interacting with it. So let me turn that off, get back here. The web server will talk to the, I think of the best way to frame this out. It will talk to the, well, the back end logic, I guess. And that's layers. There are several of these layers. Okay. Basically, when I'm typing something in and I send it to the web server doesn't it doesn't necessarily, it's not the one that determines if what is being said is gibberish or not. It's a pass through. Passes it on to something that is expecting information. Typing in taco, 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 comes through, hits something on the back-end logic. Back-end logic evaluates that path and goes, I don't have that in my list. So here's my default response if I don't have it in my list. Sends it back up to the web server. Web server sends it to the DOM. DOM sends it to the browser. Browser loads it on the page. Okay. And there are lots of things on the back end, and we'll go through some examples of how some people have their stacks set up in a more specific example outside of this one. And sometimes these back end logic layers will connect to databases. So if we're successful in the way that we do something, so let's see if I can, so I still got security metrics open here. Let me put that view back up. We're going to take out this taco, 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 taco. We're going to log in. So while it's logging in, everything that we just did touched every single layer of this stack right here. Okay, so essentially what happened is in the browser we type something in, that gets sent down to the web server. Okay, the DOM is the holding area for code that the browser interprets. So that comes from the web server up, and then up to the browser. But when the browser sends it, we send it to the web server. So the web server gets this, and it gets the login credentials and goes, I got something. I don't know what it is, but I'm the pass-through. I'm going to send it on to backend logic. Backend logic gets it and goes, oh, this is a valid page. And they're doing a certain kind of request here. They're sending me information. Yep, so it'll take a look at that page and say, okay, I have this certain kind of...
log in, this is what needs to come up. The first thing.
Well, before that, before that it says, okay, what is it trying to do here? What is this page trying to do? And the back-end logic, these layers will say, okay, I have a page for that. What does that page do? This page logs people in. Did they send us a key? And that's the password. It goes, okay, how do we know if this is the right key? So then it takes it and looks at the database and goes, okay, here are a list of keys. We have a username and a key. Let's find the username they gave us. Okay, here it is. What's the key? Okay, here it is. Here's what they gave us. Let's compare the two. Does that match? If it matches, then the logic will then take it, send it up to the web server and say, yeah, this matches. Here is where you send them next. Web server takes it and goes, oh, okay, I'll pass that along. So then the web server takes the content provided from the backend layer through the web server up into the DOM, and the browser, which just sent out a request, is now waiting for a reply, gets a reply back, okay, you can enter. Here's where you go next. And it loads in the page. And that's essentially what a web stack does. In a very summarized way of approaching it. But for that V stuff, that V model you were looking at, the layers of testing, we basically have unit functional integration. We have unit functional and integration testing happening at this layer. Okay, and we'll go into a little bit more detail about what each one is.
But that's where the testing happens.
Is on the back end and these logic layers. So before the web server, before the DOM, before the browser, you don't test it in those. You test it in the code.
Because this is where we want to make sure we find any bugs.
Since this is where all the logic is happening at, because the web server is a pass-through.
Right.
The DOM is more or less a holding area for interpretation, and the browser is something we don't really control. So we build for the browser, but we don't control. Like we don't control Chrome.
Gotcha.
We don't control Safari. We can try to manipulate it with the code, but the stuff that's ours is a little bit on the server and in the backend logic.
Okay.
Okay. There are other layers out there that I'm not quite getting into right now because they kind of fit between these layers here. But for now, we're not going to really worry about that. Also in here, we have endpoint. API. Yeah. Up here, we have I'll just call this for now Selenium. And in here we have like Karma, Jasmine. So to kind of explain what each of these is and how we use them as testers. Unit testing. Unit testing is so if we have an individual function in a page, say the page has dozens of functions, and the function has a very small purpose, right? It's just supposed to take whatever it is we type on at the end of the browser or of the URL. It's supposed to take that, pass it along, and then whatever it returns back with, we return back, send it on to the next service. The service takes whatever it is that output is and plays with it, and then sends it on to the next service, and so on and so on and so on. So we have this function that takes something and sends something out. So we have to write a unit test for it. A unit test basically says, okay, I'm going to test that if I pass purple to this function, I expect it to return me back Brad Pitt.
Okay.
For whatever reason.
Yeah.
That's what the logic says in it. We're going to test that out. So we're going to make sure that whenever purple is passed to this function, Brad Pitt comes out the other side.
Okay.
So we set up a small unit test so that we call the function, pass in purple, and confirm that the output is Brad Pitt. That's it. It's a very small test, but offers you the value of knowing that the function is still performing the way that you expect it. Okay. A functional or integration test are about the same. They're not exactly the same, but they have some overlap.
Okay.
Where essentially, if you have multiple functions that all tie into together, so you start with purple, feeds into the first function, that comes out and goes into is Brad Pitt, goes into the next function, comes out the other side as pizza.
Okay.
That goes into the next function, comes out the other side as the number 3. Next function comes out the other side as happy birthday.
Okay.
So you basically say, for a functional or integration test, I'm going to call all of the functions that are already being covered in the unit test and just make sure that if I pass in purple, the outcome after it goes through all the functions is happy birthday.
Okay.
And so we have to call them all. Instead of testing them out individually, you test them out as groups, interacting with each other or integrating with each other to make sure that there isn't some sort of breaking going on one to the next.
So what is the difference between the functional and integration? Because like they overlap.
There's
so if you were just say, I just want you to do a functional testing on this.
They're for all intents and purposes, they're basically the same.
Oh, okay.
Just you might hear them used in different terms or in different ways, but they're more or less synonymous with each other.
Okay.
So we'll do this, and I'm going to do the same with
Endpoint and API.
Endpoint and API. So with endpoint and API, basically, so you remember on the screen here how we have these 200s right here?
Yeah.
There are different methods that are used in in endpoint API, you'll probably hear them brought up as get, put, post, delete, things like that.
Okay.
Essentially, when you send a query to a web server, you say, hey, go google.com. You're making a GET request. You're saying, hey, I want to get the content for this page.
Okay. Yeah.
And it says, oh, you're looking for a GET? Let me return the data to you. If you're doing a put, post, or delete, you're sending the web server information and saying, I want you to change something for me. I want you to do something different than just return information. I want you to change information on the back end.
Okay.
So a put is like an update. So if you ever update your password, it's likely going to do a put request.
Oh, okay.
And even though it's on the same page, you can have get requests, put requests, post requests, and deletes on the same page. But those all happen through an endpoint or an API. So you do a get on securitymetrics.com. You could try to do a put on securitymetrics.com and see what happens. But essentially what we're doing here is we're saying, okay, this is how you get into a certain service in the web server. Or in the back end here.
Okay.
In the back end, if you want to interact with a service that might touch the database, you have to use one of those. And so we test out those entry points because those are like the doors. These are the pipes. And these are essentially the nozzles that hook up those pipes.
Okay.
So we have to test them both because problems can occur either where they're attached or how they're getting around. Okay. But there are different layers, so that's why there's layers here. It's plural, layers. Up here, you ever heard of JavaScript before?
Mm-hmm.
So JavaScript does some functional stuff in the browser. If you need something to happen not on your system, like on your server itself, but you want to use the browser, the client, to do all the heavy lifting for you, you can force some of the logic that would happen here to happen up here, and you can do that through JavaScript.
Okay.
So we use both so that if we're doing logic here, and we can save some time by doing some logic up here, then we could essentially have the time that it takes to load something in, because now we're using the browser to help out with some of the load of the information.
Okay.
A lot of this comes down to how the information is going to be displayed and interpreted. And you can see things like pagination. You ever seen those, like on scan results, how you'll have like pages at the bottom and you click next.
Oh, yeah.
It moves into the next view, you click next, move into the next view. That's JavaScript. All the information has already been sent to the web server, requested, the logic grabs it from the database, sends it back up to the web server, sends it to the browser. Instead of displaying all of it into the browser at the same time, the JavaScript says, okay, I'm only going to show you bits and pieces at a time, but I have all of it, but I'm gonna break it up to make it easier for the browser and the user.
Reading an article, and it's separated into different pages, and you have to click next. So it's already there. It's just going to give you
the bits and pieces that per time to improve performance in the browser and increase the user experience.
Okay.
So Karma and Jasmine, these are different kinds of automation tools that you can use for JavaScript specifically.
Okay.
So you can make sure that from the JavaScript side that the browser is able to handle the kinds of things that is being done from the JavaScript side.
Okay.
And then Selenium, this is more or less just a UI, very strictly. You know, up to this point, you don't have to worry about necessarily the browser. Mm-hmm. From a testing perspective, you don't have to necessarily worry about the browser from JavaScript on down.
Okay.
Okay. But once we get up into the UI, into the actual visual interface, then it becomes a bit of a problem, because now the browsers are going to take the DOM and interpret it however the hell they want. And so with Selenium, if you use Selenium for automation, and this is just a tool or a testing package for automation, you have to build your Selenium around the things that make all of these different. So if you would interact with an element on the page in one way in Firefox, you may not be able to interact with the element in the same way in Internet Explorer. Also, when we're interacting with elements, in this tab here you can see elements. So we're looking at these have, each of these lines here is an element. And we can interact with those with some automation. However, if this changes in the DOM according to the browser, then writing up automation for one browser doesn't necessarily mean that's going to work in another browser.
Right.
So in order to get automation to work at this layer, we quite literally have to do 5 to 6 times the work to produce the value that we can get from one test here.
Right.
And likewise, we'd have to do several tests here to kind of get the benefit of maybe one test here. And then kind of similarly, we have to do a bunch of tests here to kind of get the full benefit of one test here. However, that's where it stops. This is probably the best layer to test at as far as getting the most value from. This is because you have to write a bunch of these to equate to one of these.
Okay.
So this is kind of where, if you were to graph it out, this is where the majority of the benefit comes from. You could have multiple hoses attaching to one nozzle. So some might argue that this is where you get the most benefit from. They may be more 6s and 7s. Like it may be a toss-up depending on the environment. I think for ours, this is the most important. Though there is a lot of stress to get this, but a lot of people will ask for this kind of testing because it's sexier. And it's sexier because you can actually see it happening on the screen. Like if you do automation at any of these other layers, you just see code flying by on the screen. And if you don't know what's going on, you're going to look at it and go, what the hell is going on? With this, you can actually see it. It'll load up the browser. It will click around on the browser for you. You don't have to touch it. It will type in information for you. And it will look as though someone has taken over your computer. And you'll see it, and you'll know what's going on because visually you will have done that over and over and over again. So it's sexier because people can look at it and go, oh, I know what's going on. So for people who don't have a lot of automation experience or QA experience, they often look for this because of kind of the sexiness of how it's interpreted, especially how it's interpreted by people who've never done automation or testing at all.
Okay.
They don't understand the value of these layers of testing. All they want to do is see the bot that runs the UI and spins things up and lets things run for you.
Yeah.
Even though they don't realize that it's incredibly costly to do it here, and because of how often these companies change their browsers, it's huge on maintenance cost to keep this current. So if Chrome changes the way that their browser is reading from the DOM, it breaks the Selenium tests. You have to go back in and change or rewrite the Selenium test to make them work. If Chrome changes how they interpret things in the DOM, it doesn't necessarily break how the JavaScript is working. It doesn't necessarily break how our backend layers are responding to requests.
Okay.
It really only impacts right here. So less wise people will really look for this, primarily because they have no idea what the hell they're talking about. So if you go and look for jobs online for like automation engineers, you'll see a lot of people asking for Selenium WebDriver automation, and that's primarily because they have no idea what the hell they're talking about. They just want it because it provides a lot of the sex appeal to like executives of the company. They want to be able to see a window, just whirring through all these tests and passing
They
them
don't want to
off.
see all
They don't want to see all the
code.
code because it doesn't mean anything to them. If they can see, a screen whirring by with things and then green lights popping up showing that tests are passing, oh, that's just incredible. And that's
Gotcha.
oh man, I'm gonna go in the corner and do one of those real quick because this is doing something for me, like
Mhm.
ladies' feet. So going back to
Yeah.
anyway, anyone else that watches this will understand. So that's in a very as condensed a format as I can. Sorry that it ran so long.
Yeah.
That is essentially what a stack is.
Okay.
A web stack,
What's that?
and how the stack interacts and works with the user, as well as with the technologies built on top of the stack. And then how, as a tester, the different layers that you would want to test at and where and why they would be impactful in the stack in general.
Okay.
Okay. Yeah. Do you have any questions about that? Concerns, thoughts, dilemmas, insights, derogatory remarks, come-ons, anything?
A lot of just vocab that is new.
Yep.
But putting things together in a visual sense helps, like the functional and integration testing that makes sense, and seeing the step-by-step how it all works. Yeah.
So this word is a very
Broad.
very broad.
Very broad.
So for instance, you could be talking about a browser stack. And a browser stack could be something as simple as, let's take a look at this page, for example. So we have, oh, come on there, Taco. So this page. So as I'm hovering over things, seeing how things are lighting up there in the visual, I'm going to bring this down and show you. So right here, this is covering
everything,
the entire screen, right? Well, this is in the HTML class. Okay, anytime you start up an HTML document, an HTML page, you have to use the HTML class. This is saying this is the entire layer of the HTML class. Okay, let's go to body. Oh, look, everything in the body is in there as well. Got nothing in the head. Why? Because the head is all the JavaScript stuff. You have all these scripts down here, and stylings. And they're more or less references. But after all the stylings and references and the scripts, things that are more back-end defined, we get into the body. In the body, oh, look at this. We have a
kind of like a header.
Kind of like a header, but we can't call it a header because there's a head, right? But here's this layer. There's a layer of the stack, and here we have this other one. Oh, look, they kind of overlapped on each other, right? So if we move down, here's the main content of the screen, but in here we have other layers. So we can open these up and start moving down into the layers, into the stack. Now, you remember that scene in Iron Man where they're look at this one. This one is just this small area
space
on the page, very small, right? Remember that scene from Iron Man where he's in the cave and his buddy Jensen is trying to figure out what he's trying to build, and he's looking at all those really thin sheets of paper and trying to make sense, and he says, okay, lay them flat. And he lays all the pieces of paper flat, and they all sit on top of each other, and then you can see the Iron Man suit.
Right.
Well, that's what a browser stack kind of looks like. You have all these different divs are different layers, and so as they're loading in, they load in layer at a time and build on top of each other. So when you're in things like this, you can actually do things like, okay, here we have, let me find something good here.
Because I know I used this when I was on the sales team, talking to merchants and being like, all right, you have a web page, is your no, I can't remember the question. Like, does it accept payments on the payment page? And they said yes. So we go to their payment page, and then we ask them, oh, what's the word?
iframe.
iframe or stuff like that, and they're like, I have no idea. And that's when we go into their, like, I go into their this element, and I could see on their payment thing if it's transferring to Braintree or if it's like, because a lot of them don't know, and
Yeah.
so it's like, oh, okay, this is a, so you'll be an A-EP or something like that.
AEP.
AEP.
Yeah. So in the code here, you have all these different layers, right?
Mm-hmm.
You can play with these layers. You can do
Yeah, you can
things
change
to
it
them.
and make it look.
Exactly. You can remove layers from it if you want, and it only impacts your view. You're not hacking anything.
Yeah.
You're just telling your browser, I know you got this from the DOM. I don't care. Go away.
Yeah, we do that to other sales agents when they get a big sale and they want to wait for their on Gravity to show how much revenue they brought in, and we'll go in and change it to like negative.
Yeah.
Number.
And then take a screenshot of it and send it to them. Be like,
Yeah.
I don't know what's going on. And they're like, what's happening to me? I did on Urban Dictionary. I changed the definition of fisting to punching people. And I said it to someone on Facebook. I was like, no, I'm pretty sure that if I create a group called Fisting Assholes, it just means we're punching mean people. And then I looked up an Urban Dictionary and got the meaning and deleted it and changed it, took a screenshot, sent it to them. They're like, you must be reading a different version of it because here's what mine says. I'm like, oh man, you're dirty. You're a dirty, dirty person. I'm like, no, that's what it says. I'm like, yeah, I'm pretty sure you're just changing that too. So here we got the logo, right, for Wikipedia. So if I want to delete that, it deletes it from the page. It's very simple
and
because
you
you're
refresh
just
the screen, it's back on.
you can refresh it. I'm going to hit Control Z because that undoes things.
Oh, okay.
But yeah, I could do that and then refresh, and it will come back. So you have all these different layers that happen at different layers of the stack. You can have.
So each of these have all different layers. Like the browser has different layers, DOM has different layers,
web server's different layers,
and obviously this has different.
And
layers.
this has not just different layers, but other layers inside those layers, inside those layers, and it just keeps building down and down and down. So
it's a massive stack of.
A massive stack, and then inside of each of those stacks, you can have other stacks.
Yeah.
So
when people say stack, you have to pick up to whether they're talking about a browser stack.
Yep. And sometimes you'll have front end developers that talk about the stack, because to them the stack likely means like this stuff.
Gotcha.
And other people will have like a back end developer who will be talking about the stack, and they're talking about more like this stuff.
Okay.
So depending on who and what, the term stack changes its definition based off context.
Gotcha. Okay.
Like fisting. Sorry.
So I'm gonna watch this with my kids.
Okay. Daddy, what's that? Wait for prom. You'll find out.
That makes sense. Okay.
This is
the basic knowledge that I would need to have in being a tester.
Well, it's likely that you'll read that the base knowledge that you need is that these are browsers. And
so what's a browser again? Is that Windows like 98?
Yeah, Windows. It's AOL. It's AOL. I got some of the 6,000 free hours discs laying around somewhere. It's likely that they'll say, as long as you can use the browser, you can do testing.
Oh, okay.
And for some layers of testing, they're accurate. But to be able to better grasp why things are happening in the browser, you kind of got to understand the DOM.
Mm-hmm.
In order to understand the DOM, you have to understand the web server. And in order to understand the web server, you have to understand that there are back-end logic layers that are occurring that are. This is where the majority of the bugs end up coming from.
Right. because developers don't really plan for them. They just think to themselves. Everyone thinks like them.
Well, I don't want to be that negative against them. They do try to span their minds outside of that, but for the most part, their job is to perform the function that is defined and outlined for them, and that's done by a product manager. If the product manager says, "I want you to make me a black car with 4 wheels and get up to 60 miles an hour," and the developer will go down, sit down, we'll make a black car, 4 wheels goes up to 60 miles an hour, and a tester will get it and look at it and go, "Okay, can it go backwards?" And the developer will go, "Why would anyone want to go backwards at 60 miles an hour?" We go, "I don't know, but does it need to be omnidirectional?" And we don't know. We'll test it. We'll see what happens. We'll go back to a product manager and say, "Okay, here's what I tested. Here are my findings. Are any of these problems?" And they'll say, "Okay, here's what I asked for, and here's a big chunk of data that I didn't ask for, but I probably should have defined." And that'll give the product manager additional information. So the next time they ask for a car, they can say, "Okay,
it needs to just go forward. It needs to."
Yes, they can be more descriptive
gas.
Of the
Can't be electric.
How's it going to be propelled? What kind of safety parameters are there going to be? Are there going to be doors on this car? Probably not as nitpicky as the color and style of paint. Like color meaning like charcoal black versus midnight black or giraffe tongue black. Weird convoluted things like
Obama
that. But
black.
Exactly. Which is, I mean, according to some people, is pretty white. So you're going to get some weird things there. But that's essentially what happens with the developer. They're asked to make something, they make something, regardless of whether or not it performs the function that the product manager thought it should perform at the end. They don't build based off of a concept. They build off of a definition.
Okay.
And if the concept isn't well defined, then the product, what is delivered, isn't well made.
Okay.
But the problem is that what the tester does, the tester has to take a look at what was made, has to take a look at the concept, and then judge and weigh out if they play along. So the product person says, "I need it to get a person from point A to point B that's 30 miles away in 30 minutes without crashing, blowing up, disintegrating. They have to get there safely." And they say, "We need a black car with 4 wheels that go 60 miles an hour." And a tester looks at that and goes, "Okay, what happens if we turn the wheel? Is there an ability to turn the wheel? Is it on like a guided track?" So we take a look at it and go, "Okay, here's what you wanted, which you've conceptualized, but you haven't defined as far as how to say safely, how to convert the term safely into a functional design that a developer can then use and turn around and create into the car." So
in a way, I kind of think of it as...
Hello? Sorry, I thought I just heard a voice in my ear. Probably going insane.
So the way I kind of see it as is we want to make that product manager look like an idiot.
No,
not necessarily, but like we want to be like, "Here's what I want," and we're gonna be like, "All right."
So
we want like, "Here's all the stuff that you didn't tell us what you wanted."
We have the product manager, right? We have the dev. Product manager has a concept. Dev has a acceptance criteria. Okay. The QA tests for the user. Okay. So the PM says, "I need this for this reason." And they provide acceptance criteria to the dev. It's the QA's job to look at the acceptance criteria and the concept from the perspective of the user and say, is this sufficient? So there have been cases where the concept is wrong.
Very limited.
It's just flat out wrong.
Flat out wrong. Okay.
And the acceptance criteria then provided might be right with the concept, but is wrong for the user.
Okay.
So then the QA has to go back to the PM and say, no, we're not making this. And the dev says, yeah, but I already made it. And the QA says, I understand that, but this doesn't do anything for the user. We're not going to deploy that because that actually might cause a worse experience for the user. So no, this isn't happening.
Okay.
There may be other times that the concept is accurate, the acceptance criteria is wrong, and we'll get into this and go, okay, take a look at the user, take a look at the concept. Yes, they match, but the acceptance criteria is off. So even though the concept is good and the user is good, and they match, this does not. So now we can't.
So that's like using, maybe this might be not a good example, but okay, so we want on gravity to delete a note. Dev goes, okay, we'll bring that up. QA goes, that's not going to work. That there's all these problems. This is how not going to work.
Yeah, and there's a big conflict between PM and QA and Dev and QA, intentionally so, because the PM, the product manager, is supposed to know what the user wants, and that's why they come up with concepts and then provide acceptance criteria to meet a need they think the user has. The QA, though, we're supposed to keep product honest and development honest.
Okay.
So we don't test for development. We don't test for product. We test for the user.
So that's just like a QA over phones, where they listen to phone calls, and it has nothing to, nothing personal towards the agent, but we're trying to keep them honest and keep our from losing any, getting lawsuits or anything like that.
Yeah,
that's the kind of same thing.
Very
where
similar.
We want the user happy, feel comfortable on our sites, use our products.
Yeah.
Okay.
So even though it's part of product's job to define the user for us, any chance that we get to talk to the user, we will.
Okay.
Even if product says you don't have to, I've already done it. Again, as
we don't
QA,
ever take their...
we never take someone's word on anything. We say, okay, I understand that. I'm going to test it though.
So is it proper to say you're full of shit?
In your mind,
okay.
And maybe around only other QA. Never to the product manager or the developer. So we have to step on product's toes and talk to the user and help define whether or not this concept is accurate or not. And then what we have to do is, here's the acceptance criteria. The dev makes it, and they make it according to the acceptance criteria, but we find that this does not match this. So then we go to the dev and say, okay, we have from a QA perspective, we're going to add new acceptance criteria to your work. So the PM says this is sufficient, but our investigation has shown that it's not.
Okay.
So now we're telling you that your code is not good enough. And the developer goes, that's not your call, and we say, horseshit. It is our call, because according to the user, this is the wrong concept. And if the product manager wants this done, you can do that, but you also have to include this portion. And that's how it goes from the product to the dev, to the QA, to the user, and the user provides feedback to the product on the experience. And then that generates more information for more concepts that lead into more acceptance criteria that then QA has to go out and weigh if the concept and the acceptance criteria are what the user asks for, and if these two match up with each other.
Okay.
So there is a lot of conflict, intentionally so, to keep everyone honest and on the right track. If it was just a one-way street of PM saying, do this, and dev just making it, and QA just testing it, then there would be essentially no user that we're building for based off of only, it would only be based off of the word of the product manager, which
could be correct, but also the user could have changed their mind or thought differently.
Or perhaps they asked one user, but we find out that it impacts like 6 other users that weren't talked to. And we might have additional insight as to how those users might respond, because mainly in QA, we come from support and sales.
Gotcha.
And the majority of the tools that we work on I didn't have that view up. The majority of the tools that we work on here are going to be impacting users that QA has been a part of. So as we see things that come down, we'll use our unique experience as sales and support representatives to say, okay, I understand why sales wants that, but as a support representative, this is going to cause problems here and here and here. So we go down and talk to support and say, hey, the developer or the product manager says we need this. The developer is making it like this. I think it's going to impact you here.
That's where your job comes in, with keeping a good relation with support.
In part. There's also other more political things, but yes, we then go and talk to support and say, this change is happening. Do you want this, yes or no? And if they say no, then we go back and say, okay, we understand that you talked to one user about this and you developed a concept based off of a single user, and you provided acceptance criteria to the developer based off of the concept derived from the single user, and the developer has done all the work, and you guys want to deploy this code, but we've identified there's a user 2 that this will impact, and this user 2 says no. And if we deploy this, user 2 is going to call this a bug. And we don't want bugs, because it's going to inhibit their ability to do their job, and we don't want to inhibit their ability to do their job, because they are the user that defines this, that then creates this, that we then have to test for. So we're not going to okay this, even though you said they want it, and they built what you said you wanted, or what you said they wanted. So instead, if you want this, according to user 2, you need to do this. And at that point, it's the product manager that can say, okay, let's scrap it and do not this until I figure out more of all the people it'll impact. Or say, okay, based off of that, we need to add this to this before this can be introduced. So it's very much so a back and forth game all the time between QA, product, QA, dev, PM, and then PM user, QA user.
Okay.
It's just this giant back and forth. That's why it's not really a
so it's like
tag. Not easily definable in a process or a flow chart. It's it's back and forth, and they're going to be back and forth from here to here 6 or 7 times before it even gets here. And there could be back and forth here 13 times before we give word on if this is good enough or if this is accurate. We could have this to here 800 times so that this is never actually created. Like, that's what the majority, or not the majority, but this is what a lot of the work is for a product, is defining as precisely as they can what this is. So that then they can generate as accurate information as this as they can, so the developer doesn't have to go back and forth with the product and figure out what different parts of this means to be able to build it for them. And then if this is well defined because it's well researched, and then this is well defined because of the well defined concept based off of the really good research, then usually the back and forth between the QA and the dev is minimal. So if everyone does, in an ideal scenario, the concept that creates the acceptance criteria is perfect. The acceptance criteria that generates the work is perfect. The QA looks at it and there are no problems and it's perfect. The user gets it and their experience is perfect. The feedback they give back to the product manager is, this was perfect.
Okay.
That's the ideal. It never happens. Never, ever, ever happens. There's always some back and forth from the product manager to the dev, or dev to the QA, or QA to the product manager. Always. So, again, if you go and do some like QA 101, they'll say, all you need to know is the browser, and you'll be fine.
Okay.
That's not true. That's like saying all you need to know is the gas pedal, and you'll know how to drive. It's like, well, okay, I'm not going to be near you when you get in the car.
Okay.
Make sense?
Yeah. Well, thanks for doing that.
You're welcome. I'm going to stop recording. Do you have any questions you want to add in there?
Not right now.
Okay.